Hi, in this video we're going to be working on Chapter 2, Section 3, adding and subtracting fractions. I'm going to be working a little different. I'm going to try something out with bringing the videos and the worksheets together a little more closely. We're going to work on a problem, and then I'm going to ask you to pause, complete a particular problem. In this case, when we finish up with this, complete problem 2. We're going to do 1. You're going to complete 2, and then you're going to press play. And we'll move on from there. Okay, and I'll also pause here and set the board up with problem 3. Okay, so what we're doing in problem 1 is we need to add 7/9 to 1/9. And 7/9 is like, something cut into 9 equal pieces. I don't have to say what they are, but there are 7 of them left, and then another pan has 1 left. And so we go to bring them together, and since they're already the same size, they're already ninths, the denominator stays ninths, and we have a total of 7 plus 1, 8. Oh, 8 over 9. Okay, so pause the video, complete problem 2, check it at the back of the worksheet for accuracy, and then press play. Hi, okay, so thanks for pressing play again. And what we want to do now is we want to look at fractions that need to be added, but the denominators are unlike. And I chose 3 problems to talk about. Before we even jump in to do the problems, I'm just gonna look at the relationship in each problem, in each addition problem, the relationship between the 2 denominators. Kind of start thinking about how they relate to each other. All right, in the first problem, I look at the 6 and the 18, and I notice that the smaller number divides evenly into the larger number. So if that's the situation, then I'm going to call the denominators related denominators. And we'll come back and do this problem, but it will turn out that the common denominator is the larger. Okay, and we'll come back and break that down a little bit more. I just want to look at the relationship between the denominators in problem 5. The first denominator is a 4. It's 1/4 plus 3/5. So the first denominator is a 4 and the second denominator is a 5. And if I think now, because I noted already that the denominators were not the same and that they were not related, because 4 does not go into 5 an even number of times, I want to go ahead and write each of the denominators in its prime factorization. So I'll just say 2 times 2. Or you can say 2 squared, and this is just 1 over 5. 5 is the only prime factor. Okay, and notice that I call these 2 fractions relatively prime because they have no common prime factor. Okay, and it's going to turn out that if this is the relationship, that all we have to do is multiply the denominators and we're all set for our least common denominator. Okay, and the third kind of relationship that we need to work through is when the denominators, if you, again, notice that they're not common, and check 4 does not divide evenly into 6, so then we have to do a prime factorization. And 6 is 2 times 3, and 4 is 2 times 2. So you notice that they have at least one common prime factor. Now what we're going to have to use is we're going to have to use that a little bit more complicated algorithm for finding that rule, for finding the common denominator. So the common denominator here, it turns out, right, we can come back and like I have some numerators off, excuse me. This is 3 over 2 squared, and this is 1 over 2 to the 1, 3 to the 1. So we're going to use the procedure we saw in the end of the last section to find the common denominator. And the common denominator here is going to be where you list all of your primes and you take the larger exponent. So here we see a 1 and a 2 on the 2's, and that will be a 2, and a 1, and there is nothing else, so that's going to be the 1. So this would be 4 times 3, or 12. So the least common denominator between 6 and 4 is going to be 12. So we'll come back to that. But I just wanted to, before we jumped in, take a minute and look at the 3 kinds of relationships. These are the only 3 relationships that can possibly exist when we're just adding 2 fractions, okay? Either related, the smaller one divides the larger one, no common prime factor, 2's and 5's, no common prime factor, or at least one common prime factor. In that case, you have to go through the extra little trouble of finding the common denominator using this procedure. Also, we'll begin to gain some speed and skill, and maybe things just kind of pick up in speed, but I'm in no rush. You're in no rush. This is all about understanding the way the numbers interact with each other. Okay. So over here, we have to find our common denominator, and because they're related, the common denominator is 18. So I'm gonna rewrite each of these fractions as the equivalent fraction whose denominator is 18. Well, that's pretty easy for the bottom one because it's equivalent to itself for sure. But for the top one, we have to find a value to multiply here by. 6 goes into 18 3 times. So we are going to multiply numerator and denominator by 3 over 3. This guy here has the value 1, so I'm allowed to multiply by him, and he helps me out. Okay, so this then 21 over 18. And adding down now. Now our denominators are the same. And I add down. Denominator is 18, and the numerator is going to be 21 plus 5. And that's 26 over 18. Okay, just checking the worksheet. Making sure I worked the right problem. If I didn't, I'm just going to change it up. Yeah, that looks good. Okay, so let's go ahead and work on the second kind of problem. So you'll skip 4 for now, and you can go back and do that when we press pause. So if we realize we're in the situation where the denominators are not the same and they are not related, the smaller does not divide the larger evenly, we then must write our prime factorization. Let's just keep it consistent across the board there. So, and then the common denominator is going to be the product, because there's no common prime factor, so that I know the denominator is just going to be 20. So we'll rewrite the problem here, 1/4 plus 1/5. Each of them has to be rewritten in terms of 20ths. Okay. So 1/4, I'm going to multiply by whatever number of times 4 goes into 20. 4 goes into 25 times, so I'm going to use 5 as my multiplier on the numerator and the first fraction, and 4 as my multiplier on the second fraction. So, excuse me for putting ones here. In fact, that should be 5 over 20 plus 1 times 4 is 4 over 20, and I add them up, and I get 9 over 20. 9 over 20. Sorry if it's hard to see there. And we ask if that fraction is in lowest terms. You should put it in lowest terms if it's not. In this case, it is in lowest terms, okay? I noticed over there, I didn't put it in lowest terms, so why don't you guys, when you finish that, press pause, you can put that one in lowest terms. Okay, so let's go ahead and look at this problem. And what we saw was that the common denominator, we were neither related or relatively prime, that when we wrote the denominators in their prime factorization, there was a common prime, and that was 2. And so we use this process to determine that the common denominator should be 12. So let's go ahead and do the problem. So we're going to write this as something over 12, and this as well. So 6 goes into 12 2 times. We're going to multiply 1 6 times 2 over 2, and we get 2 over 12. And 4 goes into 12 3 times, so we'll multiply 3/4 times 3 over 3, and we get 3 times 3 is 9 over 12. And now we're going to add down, because now we have 2 12ths plus 9 12ths, and we add that up, 9 plus 2, and that's 11 over 12. Okay, so press pause, complete 4 6 8, press play. I'll see you in just a bit. Hi. All right, so we're going to look at now subtracting fractions. And subtracting fractions is very similar to adding fractions in that all of the denominator questions are exactly the same. Is there a like denominator? If there is, you just subtract the numerator, one fraction numerator from the other fraction numerator. I'll show you how to do that. As a matter of fact, I'll do one here. Suppose I have 2/3 and I want to subtract 1/3. Then because the denominators are the same, this isn't on your worksheet, because the denominators are the same, you keep the denominator, and the numerator is just the difference of the two numerators. So, okay, so I jumped in on the worksheet on a little more complicated problem, where the denominators are not like, so the fractions are not like, so the denominators are not the same, and we have to find a common denominator. So like we did a couple of minutes ago, we have to determine if they're related or relatively prime, or neither related or relatively prime. Okay, so 7 and 8, 7 does not divide 8 evenly, so I know they're not related. And now I should write each of them as in its prime factorization. And 8 is 2 times 2 times 2, 2 to the 3rd. And I see that they have no common prime factor. They have no common prime factor. So they are relatively prime, and the common denominator is just the product of the two numbers. So my common denominator is going to be 7 times 8, which is 56. Okay, here we go. So first, I'm just going to convert each of these to their equivalent fraction with the denominator of 56, then we can just subtract. So 7 goes into 56 8 times, multiplying across by 8 over 8. 6 times 8 is 48, and now 8 goes into 56 7 times, so I multiply 4/8 by 7 over 7, and the numerator is then going to be 4 times 7, which is 28. Okay, so we're going to subtract down here. 48 minus 28, 48 over 56 minus 28 over 56. So my denominator is now 56, and my numerator is going to be 48 minus 28. (20 over 56). So that's a correct answer, but it's not in lowest terms because I noticed that both of the numerator and the denominator are even. So I want to rewrite them in lowest terms. So you can do some repeated reduction, like take out a 2, take out another 2, but I'm just going to go ahead and, rewrite these in their prime factorizations. So 20 is 2 times 2 times 5. And then we can just cancel the prime factors. Okay, and then 56, let's prime factor that. 28 times 2 is 56. 2 times 14, 2 times 7. So it's 2 times 2 times 2 times 7. This is such a nice example of reduction, of having the, canceling the common factors. So I'm going to cancel 2 sets of 2's, and I end up with a 5 in the numerator and a 14 in the denominator. Is this now? This is in simplest form, so we're all set. Okay, so that's the end of this video. What you're going to do is press, actually I said press pause. Yes, I'm sorry, it's not the end of the video. So press pause, complete 10 and 11, and then press play. And I'll see you back and we'll work on number 12. Okay, so I actually decided that this is the end of this video. I'll make a separate video that starts with question number 12. So I'll see you in the next video, part 2. Okay, I'll see you in part 2.